following video was created by CS Capstone Implementation Team number 8315. Our project is the digital Notam's web application. Team members include Connor Mathis, Zachary Waters, Jay Dargula, and Eric Malavenda. This video is a demo reviewing Sprint 1 of our application's implementation. Our project's goal is to work with our client Honeywell to create a system that can read complicated Notice to Airmen, or Notam codes, and parse the most relevant information from them. Notams are currently one of the last few holdouts of modernization, as the alerts themselves are not written in any particular format or syntax. This makes designing any software around Notams particularly challenging. Honeywell now faces this challenge during the process of designing their new website. Their website is still in development, but Honeywell aims for it to be very multifunctional, allowing pilots to map out all the details for their upcoming flights, which include Notams. This is where our team comes in by creating a system that can extract useful parameters from Notams. Honeywell will be able to use this information to plot Notams directly onto maps and charts, sort through Notams by importance, and display Notams in a natural language format. Currently, pilots view Notams as either printed or digital text, which can be around 20 pages long and hard to decipher. The formatting of a Notam is not consistent across airports, but the above picture shows the general format. It starts with the airport code, then Notam number, Z code, latitude, longitude, airspace, active date, and created date. The team's first sprint toward full implementation of the digital Notams web app includes an early prototype created to demo a rudimentary search feature of our app while running an instance of our database with Spring Boot as our back-end framework and Angular as our front-end framework. Running the prototype locally yields our search for Notams page. Along with selecting a type of runway in order to only populate fields relevant to users interested in airport runway conditions, we enter ATL as our airport code. We then hit submit, and the app's backend responds by sending the appropriate data to populate in our web app's search page. Our team's second sprint will begin to highlight the efficacy of an early version of our data parsing tool, critical to providing users with readable data extracted from full-length Notams. This tool will be able to search Notams written in non-standardized and arbitrarily written formats, extracting only the most relevant info according to a user's search type selection. The data will be shown to the user requesting the Notam info upon query submission via our web app's front end. This concludes Team 8315's Sprint 1 video demo of our app's implementation.